All right, I think we can make a start. Welcome, everyone. Um, I am Cornelis van die Kerk, for those of you who do not know me. Um, I am with Weld Australia in the capacity of the manager for advanced manufacturing. And events like these are typical of the events that we host quite often. Um, I'll just admit people as I talk, so if I have a small pause, um, Sid, could you perhaps just help me admit the people as they come into the meeting, and then I can just continue with the introduction. Thank you. All right. But thank you for joining us, everyone. And just for those who have recently joined us, I'm just going to ask you if you're not presenting, to perhaps just leave your camera off, and that will help save us on the bandwidth of everyone in the meeting in case someone has a bit of a bad connection. My own laptop starts to struggle a little bit when it's strained too much in this regard. Can everyone hear me?
Yes, go ahead.
All right, fantastic. So welcome, everyone. So we've had Cobot webinars before. And what makes this one different from the webinars that we've hosted before is that this is perhaps our most forward-looking webinar that we have hosted up until this point. I'll start my introduction by talking a little bit about the where we are at the moment with regards to this technology, where the rest of the world are, the United States and China, for instance, which are probably two of the bigger key players in the global market of robotics. And I'll talk a bit more about the statistics from the Productivity Commission in Australia. So over the past few years, we've seen cobots move in Australia from a curiosity to a proper capability in the Australian fabrication and welding industries. Right, so what started as a response to labor shortages and repetitive welding tasks has rapidly evolved into something much broader. Now, Sid from Diversico will, in his talk later on, touch on some of these broader applications of cobots and how they fit into the grander scheme of things. What else do we automate? Because quite often when we talk about welding automation, we immediately think in terms of automation of the welding arc itself and the welding torch. But automation goes far beyond all of those applications as well. So we'll hear a bit more about that from Sid later on. But cobots are basically at the moment reshaping how workshops think about productivity, safety, and skills, for instance. And I'll talk a bit more about the skills in a moment. But the reality is that the industry in Australia needs a shift, and it needs a shift for various reasons. I've spoken about these statistics before, but I'll elaborate a little bit more today on them. But according to the Productivity Commission in Australia, our labor productivity in Australian manufacturing has fallen by roughly 10 to 12% over the past decade. At the same time, the percentage hours worked have increased by about 7 to 8% during that same time. All right, so this means that we're basically working more but getting less done. And this is specifically within the manufacturing industry within Australia. Right. At the same time, other manufacturing nations have gone in the opposite direction. We'll talk about China in a moment, but countries like Germany, Japan, the United States, and even South Korea, they're sitting at roughly 20 to 30% ahead of us in Australia in the labor productivity space. Right. China, for instance, has been growing in their labor productivity roughly between 4 to 6% per year. Right, so that's quite a significant growth. While Australia is not anywhere near what these countries are achieving at the moment. Right. I want to talk just a bit about China and the US for a moment. Earlier in the week, I read a report, the World Robotics Report, and it was published by the International Federation of Robotics. So if you just want to give me 5 minutes to read you some of the statistics from this report, it is actually quite shocking. And then to put that into context to how does Australia compare to these statistics, right? So I'm just going to read a few of the statistics from this report. So China is the world's most dominant power in automating its manufacturing, right? So we all actually know this to an extent. But China is currently installing nearly 10 times as many robots in its factories when compared to the United States, which is the next big player. Right. So last year alone, and these are the scary statistics, perhaps. Last year, in the financial year 24 to 25, more than about 550, so more than 500,000, more than 550,000 industrial robots were put to work in global factories, right? But China took about 54% of those robots within their economy. So that means that China has implemented in 2024 to 2025 about 295,000 robotic units. Um, and the interesting about this number is that it's actually a world record. So they broke the world record for the most robotic units installed in a single year. Which would explain their increase in productivity. I mean, between 4 and 6% per annum is quite significant. The United States, on the other hand, only installed about 34,200 robotic units within its own manufacturing industry, which is a decrease of about 9% from what they did the year before. All right. So what perhaps explains the number that China is installing. So China has a total, even though they installed 295,000 units in the past year alone, they have at the moment more than 2 million robotic units working in their manufacturing industry. And according to the International Federation of Robotics, this is because there is a state-directed industrial lending in China. So there's state incentive, government incentive for the uptake of this technology. And this is in US dollars, but a state-directed lending scheme amounting to about 1.9 trillion US dollars, which is rather significant, right? So it is really up to us in Australia to then also say, all right, look, we need to advocate more on behalf of the industry towards to government to generate more incentive for the same type of schemes. Now, I do realize that Australia has very unique problems, right? In Australia, we are concerned about local content, the cost of producing local content. We are also concerned about a severe skill shortage within the welding fabrication industry, right? We have an aging workforce, and I read a report the other day that stated that the average age of our welders currently working in the industry is approaching their mid-50s, which is quite significant. And not to be ageist about it, but where is the backfill? We need to address this problem from various angles, right? So we need government incentive to enhance our local content. We need government incentive to increase the uptake of robotics. It's just becoming more and more clear that business as usual is not going to solve our problem. Another problem faced by Australia that was also published by the Productivity Commission is that we are investing less in our workforces. There was a drop of about 30% in the investment of upskilling our workforces. And there was a further drop of about 25% in the acquisition of new technology. Right, so we're spending less in qualifying our people. We are spending less in actually acquiring the technology. And when I speak to our local fabricators, members of Weld Australia, quite often they say to me, Cornelis, both the skill shortage is a problem. If we could double the amount of welders that we have, we would run at full capacity. Second, we have a productivity problem. So we are getting arc-on times of about 1 to 2 hours max per average 8-hour labor shift. compared to other countries like perhaps Germany and the US, who are more in the 2 to 4 hour range. We have a bit of a gap there as well, right? So this is where cobots could perhaps offer a genuine practical advantage, right? They typically cost about 30 to 50% less than their industrial robotic counterparts. And they're not here to replace tradespeople. And that is something that we need to make abundantly clear. They're here to take on repetitive, fatiguing work so that welders can focus on more skilled tasks. Like you'll never send, not at the moment anyway, a robot or a cobot down a trench to weld a stormwater pipe or up a scaffold to weld a roof beam structure. So there is a place for our skilled welders, and cobots can help alleviate their current workload, their current strain, to free them up to do that kind of work. Our tech suppliers say to me quite often, when we talk about return on investment for industrial robotics, that could go anywhere between 3 to 5 years. But when we talk about cobots, the return on investment, depending on your work and the pipeline of work, could be anywhere between about 6 to 18 months. Right, so it creates perhaps an easier entry point into automation for SMEs, perhaps more regional fabricators. So they're not just, automation is no longer just for the big primes. All right, so this is why perhaps session is perhaps so timely. We've brought together some of the leading voices from across the automation landscape in Australia, what I believe are some of the top experts in the country. We also have some of the top experts, other experts also joining us simply as attendees. So if you're here, please feel free to speak up as well, ask questions, contribute to the conversation in whatever way you can. So we have speakers today from welding specialists. We have multi-industry integrators. We have digital deployment experts. We have some of the top research leaders in the country as well. And I myself will talk as a representative of workforce educators, as through my work at Weld Australia, we do a lot of upskilling of workforces as well through our welding courses. I'll talk a bit about a Cobot micro-credential that we've also very recently put together, collaboratively and sponsored by the Queensland government. But I'll just do a quick introduction of our speakers today before I hand it over to our first speaker. So from Smenco, we have Hal Mitchell-Christian. Now, Smenco, they are leading, pretty much leading the way in welding integration as well, and turnkey automation solutions. They're some of the top experts in welding as well in the country. We have Diversico as well, and Sid Amari will do a talk from Diversico for us. Sid will basically broaden the lens and show us a bit how cobots can be extended far beyond just welding automation. How can we automate different aspects of the whole fabrication process? So I'm really looking forward to that as well. We have Ben Lehman from Decisive, who will speak about digital capability and implementation of cobots. And then we have probably one of the most interesting things I've seen recently, Professor John Roberts from the Australian Cobotics Centre. He will be showcasing a humanoid robot. So the Australian Cobotics Centre are really pushing the boundaries of adaptive collaborative welding. They are leading the research in cobots in Australia at the moment, and that's cobot automation across the spectrum, including welding as well. So I'm looking forward to seeing where technology is headed with humanoids. All right, and finally, I'll close the session with an overview of the National Cobot Micro-Credential that we've developed. So we developed it in collaboration with the Australian Cobotics Centre, with Diversico and BOC, and it was sponsored by the Queensland government. So what does that mean for industry capability and training in Australia? All right, so whether you're already working with automation or just starting to explore it, so today's session is pretty much designed to give you clarity on what's possible at the moment, what is emerging, and what's coming faster than probably many people realize. All right, so thank you again for joining us. And with that, I'm going to get underway. I'm going to ask Hal from Smenco to share his presentation and to jump in first. Hal, are you ready?
I believe I am. Just checking this is sharing correctly.
Fantastic, thank you.
All right. Can't 100% tell that that's sharing, but I believe it is.
It's sharing, we can see it. Yep.
All right. Well, thank you very much for that introduction, Cornelius. Yeah, just to reiterate, my name is Hal. I'm from Smenco. We are a welding solutions provider at the core, and I am one of our cobotic specialists that has been deploying a lot of solutions across the country for a range of different processes. And yeah, I'm just going to go over what we're currently seeing as challenges in the industry. Some of these have been the case since Cobots have sort of started to push into the welding space. And these are continuing on and evolving a little bit, but then we're also seeing new challenges and new ways to address them that we're able to offer with some of our solutions. So yeah, just a quick overview. I'll give a bit of a company profile, so the main issues that we're still seeing is around accessibility, especially around getting people into and able to use cobots, handling variation, handling traditionally manual workflows, and all of the high mix variation that entails. I mean, not necessarily a new space, but an emerging space of new standardization when it comes to welding that is really affecting the ability for businesses to adopt automation in the welding industry. And then finally, some challenges that we've been continuously seeing around integration and support. As a quick overview, we're here at Smenco. We're an Australian business, family owned, based in Melbourne. We are sole agents for a large range of welding adjacent products. At the very core, it's Fronius, and that tends to be with any of our welding solutions. But we also work very strongly with Universal Robots and technology partner THG to deliver turnkey packages for cobot welding, as well as selling to robot and cobot integrators across the country. And we've been doing that to robot integrators for the last 20 years. And quick intro to myself. I am a robotics and mechatronics engineer. I studied here in Melbourne at Swinburne University. I've been in the manufacturing industry for about 7 years. And fun fact, I actually learned how to weld purely in the industry.
Are you on mute? You accidentally muted yourself, Hal. There you go.
Yeah, I'm not sure where that cut out, but yeah, so I'm a robotics and mechatronics engineer. I studied at Swinburne in Melbourne, and as a quick fun fact, I learned how to weld purely in industry for the very first time many years back now, before receiving any sort of academic theory around it. So I really understand welding as an intuitive, hands-on process, and I think that more people need to recognize this. All right. So again, sort of the key points that we want to drive, I'm going to be driving home with this is the challenges that we're seeing that both from a solution point of view, from a adoption point of view, and how we can address a number of these things with the solutions that we're selling here at Smenco, and what's emerging with our product and technology partners. So the first biggest point that's always really been the case with cobots is accessibility, and understanding who is going to be programming the Cobot, who is going to be using it on a daily basis, and what sort of skills do they need to be able to actually make the most of it, and how can you leverage that? So really, we still see the biggest driver around the adoption of cobots in the welding industry being the skilled labour shortage. Of course, there's a lot of different applications and a lot of different factors that are involved there, but that skilled labour shortage is ultimately driving who ends up using the cobots inside businesses. So we find that a lot of our customers, they need to have, or successful customers need to have someone that's, first of all, willing to actually take on that skill set. But the ideal target is someone that is a skilled tradesperson, welder, boilermaker. There is some prerequisite knowledge there. They do need to be IT literate, but they don't necessarily need to be engineers, programmers, or anything like that. And ideally, it's critical to be able to leverage that background of knowledge, that if they've been welding the parts that a business is looking to automate, they need to be involved end to end of how that actually starts with the automation. And a large part of this this challenge of accessibility is a user experience, or a user or product design problem around how easy it is to actually learn and use the system, and then that affects your time to return on investment. I thought I had another slide in there. That's right. Another area of challenges that we see as being really different from how industrial robotic automation addresses automation in general is dealing with high mix. So cobot welding systems are often sort of posed to slot in between manual operations and high-scale robotic automation, because with robotic industrial automation, you tend to look for, or tend to need, low to no mix, high volume, high consistency, high initial cost in jigging to achieve consistent results. This is all just to deal with challenges that manual welders that themselves can visually, intuitively deal with. So this is the area that cobots need to be able to sort of self-correct and deal with these challenges. So as a result of this skilled labour shortage, so many businesses are looking to overcome the bottleneck that is welding before they can address any of the upstream processes that would normally really improve the consistency of a automated welding process. So this might be CNC cutting, edge preparation, design for manufacture, that sort of thing. So the initial scope of welding with a cobot is often more challenging when it's a new business to automation, because they are using manual fixtures. They've got workpieces that are tacked in place, pretty loose fitment, and especially in heavy fabrication and some sort of more general fabrication areas, you might have tolerances positionally for lugs, for braces, that sort of thing. There might be anywhere from 5 to 50 mil out of place from where it might be on a drawing or between parts, just because it's not actually critical to the overall design. And if that's something that is really easy to deal with from a manual perspective, and we're trying to introduce a cobot into that same space to just deal with that labour shortage and that productivity problem, we need to be able to deal with that on the cobot as well. Ultimately, there's a lot of different elements and ways that we can deal with these things. But one of the most critical ways that we can deal with this with a cobot is just having an easy to use system that is still very flexible and can expand to needs. So if it's intuitive to use, it's got a low learning curve that the welder can get in there, teach the part. They can spend more time tacking up, improving their upstream process before they actually hand it on to the cobot, versus just doing the repetitive welds themselves. Another area that cobots really excel in, that industrial robots can't deal with really at all, is being able to move a cobot up to a larger workpiece and deal with automating large workpieces or small areas of large workpieces that otherwise you would need an enormous scope of a weld cell to sort of deal with, from both a safety perspective and just a volume perspective. Then compensation systems are also quite critical here as well. So being able to use some more advanced functions that for us are available on the Fronius systems, on the CMT ready systems. So using things like wire sense and touch sense to self-correct for variations in the fit up, in the seam preparation, and also compensate for distortion using seam tracking as you're welding and going along on much larger workpieces. And also worth mentioning that advanced welding processes can really help deal with that variation as well. So by having lower heat input, say with something like Fronius' CMT, or with PMC for stabilizers that just let you deal with more rough surfaces and changing its stick out and that sort of thing. These greatly benefit the ability to deal with that variation. And another thing that we see a lot that adds complexity to this, but ends up being a benefit to the end business, is we quite often see businesses that are manufacturing their own product, starting out in steel because that's what they're familiar with from a manual perspective, end up moving to other materials, tend to end up moving to aluminium, which they may not have had the skills to do previously, because of the consistency and the ease of use of, say, a Fronius CMT and THG system. Another more of the emerging area that we are seeing pop up more and more as not so much a blocker, but just a challenge in adoption for cobots, is standardization and certification around the welding process. So this is more so around your WPS, and depending on exactly what standards certain industries are adhering to, in pretty much all those cases where they do need to adhere to a standard, it's absolutely necessary to fully requalify procedures to move from a manual process to automation, which has a pretty significant overhead when it comes to your quality staff, welding engineers, that sort of thing, to do that certification. And that is something that we really need to be able to deal with, and we've got some emerging solutions here that we're sort of focusing on going forward. So utilizing more of the sort of industry 4.0 platforms from Fronius, that's WeldCube. There's sort of two variations here. WeldCube Air lets us reduce the amount of administration and management and complexity involved in creating and maintaining WPSs, and also deploying them to a fleet of systems for both manual and automation. And then we also have WeldCube Premium for doing more deeper, fine-grained analysis around weld seams that may be necessary for more complex and novel applications. But in either case, another area that really reduces the amount of overhead here is the standard welding procedure packages that we can offer, that depending on the standards that a customer needs to adhere to, they either act as a baseline or as a full set of WPSs that can be used and essentially just hit the ground running with the Cobot on deployment with a full set of parameters, everything like that, good to go. So you don't have to worry quite as much about retesting and starting from absolute scratch. And sort of a final challenge point that I want to discuss here is integration and support. And ultimately, this is not a new challenge, but it's something that continues to evolve, and we still continue to see it today. So companies new to automation really have the technical skill to integrate the robot themselves, and realistically, they shouldn't need to have those skills themselves from a safety perspective, and from just a focusing on doing what the business doing. Letting a business just focus on what they already know the best, which is welding, fabrication, the manufacturing itself, not trying to reskill their guys just to set up a system. So support here is really critical when it comes to understanding that it's application first, it's welding first. It's not necessarily a robot problem, it's a welding problem. And if you're not supported, if you don't have a welding process right, the whole system is essentially useless. So from our perspective, we always ensure that is the start point, making sure that the welding is covered before anything else. Another area where that initial integration and deployment makes a big difference is turnkey. And traditionally, turnkey might mean to most one size fits all. Our approach to turnkey, and what we've found works best in industry, is it's turnkey in the sense that it's fully tested, ready to go on deployment, but it's still fully customized and flexible to application needs, exactly to the customer's requirements, and can be expanded as the customer experiences growth in both their own knowledge and capability and capacity to work with new work pieces, material, and that sort of thing. So that continuous integration support is essential to be able to allow customers to expand, to retain their staff as well. So making sure that the people that we may initially train still feel confident, have the backing that they need to move to some of the more advanced programming elements. And also, if and when people do eventually move on, that business has the ability to have someone come in, retrain any new operators, any new programmers, and not be stuck in the same situation that they had when they were only relying on their manual welders and just hoping that they can keep up with the labor. So that ongoing support to us on all levels, and with the three previous points and a whole variety of other challenges that we see, it's absolutely essential to be able to be supported. So to us, as a bit of a conclusion here, the most successful customers that we ever see are empowered to use their systems. They're empowered to take full ownership and do whatever they want with it, so that we can just back them to expand their capabilities. I think I've gone a little bit over there, so I'll hand it back over to Cornelius, but take some questions a bit later.
All good. Thank you, Hal. I think we can take maybe one or two questions, if that's all right.
Yep.
Is there any questions from the floor? But also feel free to post a question in the chat if you don't want to speak in front of everyone. Van asks who sells the machines, but I guess that's Menko.
We among many do sell machines. Yes.
Yeah, there are various tech suppliers operating within Australia at the moment as well. Smenco being one, Lincoln being another one. There's quite a few around. If anyone is interested, can also get in touch with me and I can send you a list of the trusted suppliers, but Smenco is one of those on the list as well. There's a question, do you have a rep in Sydney?
Yes, we do have a branch office in Sydney. Yes.
Okay. Yep.
Yes, feel free to reach out to us.
Everyone. Everyone, you can also email me if you want more information on these topics as well. I have one question, Hal, if you don't mind. So how easy is the seam tracking on the Cobot system at the moment? So when you have poor fit up, for instance, or distortion during the welding process, how good is that and how accurate is that, would you say?
It is dependent on a few things about the weld seam itself. So there are limitations to seam tracking, but for most general scenarios where you would use seam tracking, it is material restricted, but for steel and stainless steel, it is very easy to implement. And what is also important when you use seam tracking is that your initial start position, wherever you started welding, is good. So actually, that seam tracking combined with something like wire sense, which is where we can use the wire as a sensor, and sort of do a scan across and start with a good place, start weaving, start tracking, works quite well.
Through a voltage control, in a sense.
Yes.
Yep. All right. So there are a few more questions in the chat. Srini asked a good question, actually, and I'm going to ask Sid to answer Srini's question during his talk, actually, where Srini asked, thanks for the presentation. I was wondering, are cobots suitable only for repetitive tasks, or can it be effectively be used for a wider range of applications? And I think Sid will address some of that within his talk as well. James asked, if you are working off jigs, does the system calibrate itself?
It's a bit of an unspecific question. There are ways to calibrate a system or to set up a program based off a jig and sort of use that as a datum as you would in, say, more of a CNC machining way. That is a good way to deal with large workpiece variations. That's typically what we would do when we have a mobile system that we move up to larger workpieces or just move around a lot more portably around the workshop.
Okay. Thank you for that, Hal. Thank you very much. In favor of the time, I'm going to hand it over to Sid. Wait, there's one more.
Hey, Cornelius.
Yep.
Sorry, it's Thorin. Thorin from AML 3D. I did want to ask, Smenco, obviously, there's as you said before, it's ideally you would bring a experienced welder into a robotic or cobot area. Having that expertise is advantageous. Is Smenco or is Weld Australia doing anything in collaboration with the TAFEs in education on that front?
At the moment, I will talk a bit about the educational piece towards the end that we've started. But yeah, there is a plan to generate a broader educational piece incorporating into TAFEs and having that conversation with more RTOs as well. Yeah, I'll return to that later on, Thorin. Do you want to comment on anything of that nature, Hal, from Smenco's perspective?
I'll let you comment on that more so later on. Okay. But I will just say we do work with a very large range of TAFEs across the country. in very diverse ways. One challenge there is that all of the different states, and depending on which state, it can be very disconnected in the way that they operate.
All right. Just in favor of time, I think it's time we will have to move on. But before we move on, another RTO that also does a bit of education around cobots is Stephen Love from your end. Do you want to maybe just make a quick comment, if you can? I saw you commented in the chat.
Yeah,
So
thanks
the Outsource Institute.
Yeah, thanks for mentioning us. Yeah, so we have done some cobot work as well, both with Diversico and at BOC. So we are open to helping businesses if they have a cobot in their location to help set it up, train, and do some accreditation in that space as well. So, and again, mention there that there is some state-based funding that is available. So yeah, if you want any more information, you can contact me. But yeah, I'll let you move on because I know you're short on time.
Thank you, Stephen. Just put your contact details in the chat. All right, so I'm going to move on to Sid Amari from Diversico. Sid, do you want to take the floor and share your presentation?
Perfect. Thank you, Cornelis.
Thank you. And I'm also going to ask if we could keep it maybe to like 10 to 12 minutes, just in favor of time.
No worries. I do notice we're already a bit late on the schedule, so I'm gonna be as quick as possible. Thanks for this. Hi all, I'm Sid Amari. I work for Diversico and I'm in charge of the collaborative robots division of Diversico. So today my plan is to kind of open the horizon, show you what a cobot or collaborative robot can do through few applications, right? So before that, I'm just gonna go explain a bit of what my company does, and then we can get on with it. So Diversico, some of you know us as different names. Diversico names has been created in just before, like close to a decade ago. But before that, we were well known as AccuWeight, UltraHawk, RTS, Kako. And throughout those companies, we were working within a lot of different industries: manufacturing, food and beverage, transportation, warehousing, distribution centers, and so on and so forth. So in 2017, all those companies had been put under one company name, which is Diversico. Diversico now, we are well known for two main categories. The first one is weighing industry, so with the load cell product inspections, and the other part is the automation, which fall under the robotic division. So within the automation, we work in the intralogistic, the product inspection, robotic automation, and industrial weighing. Today we're going to focus on the robotic application, and more specifically cobots, as you all understand by now. So a couple of words about the cobot. So the first cobot has been commercialized in 2008, so close to 2 decades now. And every year this market actually is growing bigger and bigger. The latest number says that, you know, in the next 5 to 6 years, we might 10x worldwide. So it's still a lot of application, a lot of things to do within the cobots industry. But I do believe that in the past couple of years, you know, maybe up to 5 years, the cobot has reached maturity. What do I mean by this? So more than, you know, if you look at the capabilities of the cobots 2, 3, 4, 5 years ago, we were pretty much limited by a couple of characteristics. So a cobot can be defined by 2 characteristics, which is the payload, the capacity of the robot to lift a certain weight and the reach, so that capacity of reaching a distance from the center point of the cobot. 4 or 5 years ago, the limitation were, let's say, up to 5 kilograms payload to 1 meter. That kind of what the cobot was done for. In the past few years, huge advancement has been done, and now we can have a payload capacity of 30 kilograms for our latest version of the P series there, up to 2 meters reach. So it opens the door to a lot of application that we couldn't do it only like 5 years ago. So Diversico, just to give you a last point about Diversico, we are a true integrator. So we are a robotic integrator specifically, and we work with Doosan for the collaborative robot and Kawasaki Robotic for the industrial robots. So that brings me to a point. What's the difference between a collaborative robot and a robot? The main differences is the payload, the payload, and the safety. So those industrial robots, some of them can have a payload up to 2 tons. As I said, the Cobot is limited to 30 kilograms. But that's the limitation mainly. But if we respect that characteristic, then it opens up application, because the Cobot, by definition, can work with humans, as we all know. I'm just watching at the time, so I'm going to go really, really fast. Cobot is safe to use around humans, can work alongside humans, as long as we do a proper risk assessment. There is a low maintenance. Those robots can run for 10 years without a maintenance. And that allows them to low-cost deployment and a fast return on investment, which means it's a perfect solution for a small or medium industry. And I used to say that a Cobot is perfect to enable small to medium, even large company into the automation. If you have like a fully manual production and you want to automate, starting with the Cobot, it's the way to go. Before someone asked if a Cobot can do one task. Yes, it can, but is it a good way to do it? Maybe not. A Cobot will be perfect for repetitive tasks, labor-intensive tasks, and potentially a non-work-safe environment as well. So when we implement a Cobot into a factory, we have to design the task to the robot, right? And that design takes a bit of time. So if he's doing only one-off task, there's no actually advantage. The advantage is when the task is repetitive. You have to do the same task one time, 2 times, 3 times, days after days, week after week, month after month, years after years. It can be many tasks, but repetitive tasks in themselves. So that are actually when we install a Cobot into the factories. Let's go through applications. So we all talk about, sorry, I'm just going through all the time. We all talk about the weld application, which we all know it by now. So we have this product here where this well-made machine is a out-of-the-box ready machine. We pretty much can go to your factory, set it up, and within a day, you can have a running welding robotic machine that can, ideal for parts up to 2 meters long or reach around the robot. And we can do MIG or TIG. We actually partner with Well Australia and BOC to build that machine. I have a small videos here to show you. Today I'm going to show you a few videos. Just going to turn off the music. And and it will allow you to kind of visualize what the cobot can do. Here we have a part when we want to do welds all around that part. So the robot starts by doing one side, go along and perform all those welds, and then the robot can actually turn the machine into the other welds. So again, ideal for parts, let's say up to 2 meters long. Okay, let's move on different applications. So here, for example, another application that we can automate via a cobot is polishing, sanding, grinder task. Again, those tasks can be repetitive, labor-intensive, and potentially no non-self-compliance. If that's the case, again, using a cobot makes sense. So we literally replace the arm of the operator or worker by a cobot, and then you can, does it not work? Okay, it doesn't work. So you can actually polish, sand, or grind a part. The good thing is about the cobot is they have a torque sensitive function to it, so it can actually apply a certain amount of pressure, let's say 1 kilogram or 2 kilogram of pressure to the part, and then you can control the polishing, the sanding, and the grinding functionality. Next application, here's a video. Okay, so now the cobot can bring the polisher to the location we want to polish and then go along a predefined part. Again, we can monitor the pressure we apply to the part. Next application here, another application that you might want to hear as well is the machine tending. So machine tending is the action of putting a part to a CNC machine and retrieving that part. So again, this task is highly repetitive and can be labor intensive and potentially non-work safe compliance. Actually, I've done it in the past where we were short of staff and we have to build, I think it was 100 and 150 part via a CNC machine, so I had to stay in front of the machine and just load the part, wait for a couple of minutes for the part to be processed and pick it up, and do that 100 or 200 times during the day. Again, very annoying and boring task. So I have a small video as well to show you here. So we automate that process. And for example, here that machine is an old machine that is not automated. So the cobot can actually open the door and press the button. We can kind of design those type of functionality to make it work into a current machine that you might have. So we're loading the part, we will close the door. We're closing the door and we're going to press a button. To start the process. And then when it's finished, we're pressing the button, opening the door, and pick up the parts and putting back into the tray, and so on and so forth. We're doing that. You know, I've seen machines that have like 100 parts, small parts in it, and you can do it one after another. Another application here, I'm going to stop this one, is a carton erector. I'm mindful of the time, so I'm going to go really, really quick. Here, application is to open the box for a production line. It's carton erector and case packer. We have to fill up that box. So we have a robot to open the door, another robot that can fill up that box. Again, repetitive, we can do it over and over again. We can have different size of box, different parts, different speed. We can make them custom for you. I will not go through the video. I don't have the time, unfortunately. Here, another application, really quickly, a pallet mate when we have to palletize boxes. Quick word here, Diversico, as I said, it's a robotic integrator for and foremost. So we can actually design and simulate application for you in this application. By designing these, we can actually confirm the speeds, the rates, and all other characteristics of the application. We supply that as a proof of concept as well to our customers. Next one, sorry, okay, go ahead. Another application for labs. The last thing I wanted to speak and tell you is for highly complex part, we can have different robots working together. In this application, obviously this is a demo. We have a polisher, a vision inspection, and we're checking that the part or the car here has been built correctly. But the next application here, that's the one I wanted to show you. Here we have 4 robots working together. Here, one of them is picking up a place. One of them on the side is picking up another part, pick and place. This one here is welding them together, and the long arm robot arm here and picking up other parts as well. They're all working together. We have 3 pick and place robots and 1 welder. And by all of them working together, we can actually create, complex parts, like in this instance, a plate. Just want to show you like the welding process here. So we can go through different weld, different direction. We can even bring that robot and flip it as well, if you have like different weld to be done in both sides. There's limits, but we can do a lot of things. So here it is. I think go through a lot of application. As I said, the idea here is to show you what a cobot can do. A cobot can work alongside human in a safe environment upon a risk assessment. If you have any question, please reach out to me. You have my contacts in the screen right now, or reach out to Cornelis, and I'm sure he's gonna supply you my information. Thank you very much.
Yeah, I think we have time for probably one question. And then if there are more questions, please post in the chat and we will try to get back to you. But yeah, thank you very much for that, Sid.
Thank you.
Do we have any questions for Sid? All right, Sid, thank you very much. Oh, there's one from Matt.
Yeah, I just had a quick question. Were all those videos from Australia, or were they from around the world?
They're actually in Australia. All of them are in Australia. So they all videos that we have done, Diversico has done. They're all in Australia in different states.
Thanks, Sid. Cheers.
Right, thank you very much, Sid. Sadly, we will have to move on to Ben. Ben Lehman from Decisive. Are you in here?
Yes, I'm here. Hello.
Hi, Ben. So you're up next.
How you going?
Ben,
Thanks,
if you can
Cornelius.
keep it to about 10 minutes, that would be fantastic. Thank you. We're running very short on time.
Thank you.
Thank you.
Just let me know once you've got the presentation up. Seems to be slow.
Have you shared it?
Yeah, I'm sharing.
There we go. We can see it. You can go ahead.
You've got it? All right.
Yep.
Thank you. All right. Well, so thank you for having me, first of all. And I'm Ben Lehman from Decisive Technologies. We are automation experts, and we hang on 2 seconds, sorry. So we're automation experts with a broad experience across mining, manufacturing, and food and beverage industries. We have a pragmatic approach, and for our welding projects, we partner with welding experts. So they bring the welding knowledge, and we specialise in the automation expertise. And with these partners, we're solving the challenges that manufacturers are facing. Every application that we come across is unique, so our value, I believe, is in delivering the right solution and choosing the right technology for the application. And today, I mostly just want to share with you what I've learned from installing. We've installed 10 robotic welding systems over the last few years. Some real lessons from real customers. All of our systems have been with Universal Robots, and they've been equipped with Smooth Tool software by a company called Smooth Robotics. So we're a premium partner and a authorised Queensland distributor of Smooth Robotics. So firstly, what is Smooth Tool? It gives you it's a hands-on, intuitive weld programming interface, and you don't lose advanced control capabilities. It works with power sources from all major brands and comes with a lifetime license that includes future updates as well. The real point of difference with Smooth Robotics is that they're a dedicated welding software company. The existing feature set shown on the screen is quite comprehensive, and it's just in the last year they've released the touch sensing, surfacing, and seam tracking. And the capability keeps expanding quite quickly because this is their sole focus. These are some real results that are possible with Smooth Tool. The technology and the capability is proven. But my top learning from implementing the technology is that the technology alone is not going to create value for the business. It's the results only come through a commitment to the technology, proper planning, and a real desire to want to make it work. It's important not to think that the robot is a magic wand, and it doesn't matter what brand or software you're implementing, and the features will only matter if someone's willing to use them. So you need to find someone who wants to make this work, and without that person or people, the robot will most likely sit idle, which is not an outcome that we want, or I'm sure that you want either. So somebody needs to champion the cause, learn the ins and outs, and persevere through challenges to find solutions, and this is particularly relevant for welding. The robot, it should just be treated as another tool in the workshop. So is your team ready for this? We've got some direct feedback from our customers that they recommend dedicating someone for at least 3 months to focus on jig building, programming, and production implementation as their core job, not as a side project. And they also insist on training multiple people in each aspect of setup and use. And they recommend having a plan for who's going to program the system and who's going to operate the system. Programming does require skilled welding knowledge, so someone who knows what parameters to adjust when things aren't right. Important to note that this person doesn't necessarily have to be good at welding themselves, that it's the knowledge that is required. So there's a key difference there. But once programmed, then a lower skilled operator can run the system, potentially in half the time of manual welding with better quality results, which the goal here is to free up your skilled welders to then oversee production, provide training, and focus on quality improvements. So you want to leverage the existing skills and not replace them, which is important for your team to understand before starting out. So then the next thing is a specific plan to achieve ROI quickly. So what specific parts are going to give you a quick win? What batch volumes make sense? How much time can you save per component versus programming time? We can help you answer some of these questions and think through the process. ultimately to get you to a point where you're confident in a plan. Smooth Robotics also have an ROI calculator, and to help. I've put the link in the chat, but keep in mind it's in euros. So they're based in, Smooth Robotics are based in Denmark, so it just needs to convert to AED. But the real value in it is in forcing yourself to think with specific numbers rather than thinking vaguely. So this is a specific example, drilling down to a specific component and analysing the productivity gains. This particular customer nearly doubled their output capacity. If you're running smaller batches or have a high product mix, it's best to have a spreadsheet, covering multiple components and planning it out so that your robot can reach full capacity. And again, this is something that we're able to help you with. And then once you've got a plan for your ROI, you need to start thinking about the process flow. So how are your parts going to be positioned repeatably, or do you need some more advanced software to track? How are you going to ensure parts are manufactured within tolerance? How do you move parts in and out of your cell? How and when are they jigged and tacked? And most importantly, how can your people be productive while the robot welds? Because that's where you're going to get your ROI from. You need to account for the setup time, loading, unloading, and the weld time. And if you do get all of this right, you can start to multiply your capacity without increasing pain and headaches. So approaching programming, you want to do it methodically. You first spend time setting up jigs correctly and trialing them before you go to the robot. Then focus on getting the weld parameters right, and you don't have to worry about tweaking robot speeds and angles until later on. To get the robot travel speed estimate, you can just do that with a manual weld as well along a set distance and time it. And then think about controlling the jig location and designing reference points on the jig so that you can validate that the jig is in the correct position before you start. And then plan your weld sequences to spread the heat and pause to cool down if required. If you're starting out, I recommend to learn the technology with simple applications, and then only consider touch sensing and seam tracking when it's essential, or if you just can't get your parts positioned repeatably. Touch sensing and seam tracking are great features that they do add some programming time, run time, and an extra layer of complexity. So I don't want to overwhelm you with the challenges. However, I do want to make you aware of it. Everything that I've discussed, we consider throughout our project scoping and delivery, and we're here to try and make the process as smooth as possible for you. We can provide access to the welding experts, and Smooth Robotics also have a full suite of online support for the programming. And then our decisive team are only a phone call or email away, and will always help troubleshoot problems to the best of our ability. So yeah, if you follow these principles and commit as an organisation with a culture of perseverance, I'm confident you can successfully implement robotic welding and achieve ROI. The technology works, the success comes down to execution. So feel free to reach out to me if you've got any questions. And I do have a short video on, it's a practical example of how a cobot and a welder can work together. If we've got time.
Hit the go button.
Thanks. Oh, did it go?
No.
Yep. It was good.
Okay.
We saw it.
Thanks, guys. No worries.
All right. Thank you very much, Ben. Ben, there's a few questions in the chat. If you can answer some of them fairly quick, that would be fantastic, because we're going to run out of time very soon, and I do want to get to Professor John Roberts on the humanoid cobot as well.
Yep.
So just one or two questions we'll address real quick. What is the normally allowed tolerances that a robot can adjust?
So if you're not using your touch sensing or seam tracking, you probably want to be accurate within a millimeter. Outside of that, you need to be sensing or tracking the seam.
Ben, Professor John Roberts said he has to leave in about 7 minutes, so I'm going to give the floor to him. Professor
Yes,
John,
no
do you want
worries.
to hop in? Sincerest apologies for being so rushed towards the end. Thank you very much, Ben.
Hey everyone, sorry, I've got to dash to another industry meeting, but let me first of all try and share these slides. So just give me a second. Just bear with me. Almost there, almost there. Can you see those?
We can see it.
Okay, so I'm going to be very, very quick here because I want to show. Oh, it's some autoplay. This is better. It'll keep me going. So could humanoid robots be the next welding revolution? So we've talked about cobots, which you can see on the left. But maybe in a few years, actually, they'll be redundant. I'm cheekily calling them cancelled here. So this is a bit of thoughts for everybody. Will these new humanoid robots actually replace them? So we're starting to use those in some of the places where we'd use cobots just to understand what's going to happen. We've got our first humanoid robot at QUT. You can see it here. This is the day it arrived. Walking into the building. We've got another two on the way. We're going to be doing all sorts of experiments with these robots to sort of compare them, particularly in their flexibility of use against cobots. As you're probably all aware, because you'll see all these things on LinkedIn constantly, these robots are becoming very capable. About 6 months ago, we thought a lot of these videos were fake. It turns out they're all real. And in fact, this video reel I've got here was made in May, and it's all very out of date now. Some of these same robots can do backflips. They can do anything. It's very, very impressive. What these videos don't show you is the repeatability of some of these tasks. So, obviously some of these things don't work all of the time. We had a seminar by one of the companies featured here, I won't say which one, which said that most of their completion success rate's about 40% in tasks at the moment. So they've still got a long way to go, but it's showing kind of what's possible. Welding specific, there's a company in the US called Persona AI who is going to sell welding robots, humanoid robots, I should say. They've got a lot of investment. They've signed up with some shipyards recently. They're oversubscribed with investors. It's very clear that humanoid robots will be used for welding very shortly. Right? It's all coming. We are because the welding task looks like it's being solved. We're working on grinding, which of course is adjacent to welding and is often required. We're starting to do experiments with cobots on cheap audio feedback on grinding tasks, and our next job in the next few weeks is to switch this to humanoid robots. So we should be demonstrating similar capabilities on humanoid robots by the end of the year. This looks relatively straightforward. Of course, there's all sorts of other technical issues to solve, but we are kind of getting there. If you're in Brisbane, we have got an event to come and meet some humanoid robots on the 30th of October at our Kelvin Grove campus. So please look that up. We've got another event on the 26th of November where you can actually get some hands-on experience with cobots. So we may take a humanoid robot there if you want to have a look at it, but it's mainly focused on traditional cobots. So have a look at that. I will stop sharing that screen, and I will quickly, if you've got time, I will just want to quickly show you. Behind me here, I've got our current humanoid robot. Let's see if it will wave to you. There we go. So this robot's already extremely capable in a sense of, it can move around, it can get up off the floor, it can do all of those things. What it's not so capable yet of is doing very good things with its hands. So that's the latest thing. And it's also not very good at planning. So a lot of the research activities will be based on the planning of the task, and also sort of robot themselves recognizing when things haven't worked and when it's got to replan. So these are the kind of the active research things. Okay, all right. So I've got a dash in 2 minutes. So hopefully that was quick enough, Cornelis.
Thank you very much, Professor. That was fantastic. If I knew you were in such a hurry, I would have put you earlier.
That's all right. I'm always in a hurry.
Exactly. It's the nature of being important. But thank you very much for that, John. Do you have time for a question, or do you have to dash?
Yes, I've got 1 minute. So question.
Let's have a quick look at the chat. If does anyone want to ask a question directly to Professor John?
Yeah, why not, Cornelius? Hey, quick question. I had a project in uni where we had these motorman or something, these robots with 2 arms back in the days. Yeah. So I came to the conclusion, why using an expensive 2-arm robot when you can use 2 simple robots, right? The same with the humanoid. Like, it's great to have that, but is it really like efficient? Replacing simple tools?
I mean, these are because of these are going to be mass produced. This is where it comes in. So the cost is going to be relatively low. This one you see behind me here isn't cheap. It's $45,000. But for that, you get the 2 arms, you get sensors, it can walk around, it can do all that stuff. And when they're mass produced, they're going to be a lot cheaper than that. So also, you can see these things as, even forget the legs. If you rip the legs off and just sat this on a workbench, you've got very affordable 2-arm solution with built-in sensing. So it's the fact that they're going to be produced at a much greater scale than cobots are now, for example. So that's the main thing. And also they're going to be made in the form factor of us, roughly. So any of the tools that current people use, in theory, will be able to be used by these eventually. So there's an efficiency in not having to rejig the tools themselves, but just using the existing tools. So that's the other attraction.
Fantastic.
Great, thank you
very much.
All right, Professor, I'm going to hop out now and get to my next meeting. But bye, everybody. Good to see you.
Thank you very much. See you, Prof. Thank you, everyone. That pretty much brings us to the end of the time that we've allowed for the webinar. However, I do want to just quickly share, I'll literally only be 5 minutes, just a short piece on, a short presentation on the micro-credential educational piece that we've prepared with the Australian Cobotics Centre as well. My computer is also just a little bit on the slow side, but can everyone see my presentation?
Yes, we can.
Okay, fantastic. All right, so I'm going to be very brief. This was a collaborative effort between World Australia, Professor Roberts from the Australian Cobotics Centre, Diversico, and BOC. We've created this after receiving sponsorship from the Queensland government in order to create this micro-credential. So I'll just give a brief overview of what the micro-credential is. So after speaking about all of the problems faced within Australia, the 10 to 12% reduction in labor productivity, the 7 to 8% increase in hours worked, the skills shortage, the 30% reduction in investment into our workforces, it is fairly clear that we need a little bit more than just machines and then just investment into machines, but it becomes a people problem rather than just a machine problem. So in investing in the skills of our people, we will not solve all of the problems, but move towards a solution of some kind. Now, this course was created directly to address these responses, these problems in our industry. It is a fit-for-purpose course, but what I want to highlight as well is that this is a free course offered by Weld Australia. It's a short course as well. It's probably around 2 to 3 hours long. And it was created with the industry, with educators, and with actual integrators, and it covers pretty much the fundamentals of cobotic welding, starting with welding fundamentals and how cobots apply to that and to the automation of welding. It'll take roughly 2 to 3 hours to complete the entirety of the course. And like I said before, it is free, but I must just state that it is free only up until the end of October. So if anyone is interested in doing this course, I would really encourage you to do it as soon as possible. After October, we will have to, then the grant money basically runs out that was given by the the Queensland government for this course, and we'll have to start charging a small fee for it. But who was it made for? So it was made for welders and welding apprentices, but it was also made for the decision makers of certain businesses. So if you have, for instance, a peripheral interest or even just peripheral knowledge of cobots, how do you go from that peripheral interest to realizing the need for automation to actually purchasing and acquiring this type of technology? So the course takes you a bit through that decision-making process as well. What do you need to be aware of? What are the questions you need to ask of your tech supplier or your integrator? So it's pretty much for the whole broad spectrum of welding professionals, from welding apprentices right up to business decision makers. What you'll learn, basically, it's structured around 5 modules. Each module takes around 20 to 40 minutes to get through, starting with the fundamentals of welding and how that relates to automation processes, introduction to cobots in welding, its capabilities, but more importantly, what it can and also cannot do, which is an equally important thing to look at when you're thinking about acquiring technology. Equipment integration, what are the setups like? What does human-robot collaboration truly mean? Workplace applications and decision-making. And then we cover a few case studies of real-world case studies of where cobots have actually been really beneficial to certain industries. Right. So cobots offer a fairly lower entry point into automation when compared to industrial robotics. Roughly 30 to 50% less upfront cost when compared to industrial robotics. And like I said before, about a 6 to 18 months return on investment, depending. Other good things about cobots and that the course also highlights are things like the safety aspects. As Sid mentioned earlier, there's no need for safety cages due to the collaborative nature of the robot, due to the sensors inherent in the robot. It also, for instance, takes your welder out of the welding fume, the welding plume, especially in the downhand position when you're welding. So that perhaps could negate the need for PAPRs in some cases. But yeah, it just highlights all of the good and the bad around cobots. Right, how to access it? There's a registration link in the webinar invitation that I sent out to your calendars. But also, please feel free to just send me a direct email saying, "Hey, Cornelis, can you send me the registration link for this?" If you want to enter yourself, or even if you want to enter your entire workforce, we're more than happy for the numbers. We're also looking for more partnership opportunities with TAFEs and RTOs and other employers going forward after we have finished running the free part of this course, which is funded by the government. Right. But yeah, that's pretty much it. So a final message regarding it. Australia needs a practical and more affordable solutions, especially with regards to the training of our personnel. And a free solution like this is perhaps a good starting point. Now, look, this course is not going to teach you everything that you need to know about cobots. It does touch on more technical topics as well, such as how does qualification work, which standards are at the moment relevant in procedure qualification, personnel qualification, and finer details like that. But yeah, it's not the beginning and end all, but it's a good start. So yeah, please feel free to drop me an email if you're interested in it, or just have a look at the link in the invitation, and I'll register you. Usually we register people within a week after reaching out. And yeah, like I said before, the course only runs for 2 to 3 hours in total. It's self-paced, it's fully online, and it's free. So I'll finish with that. I'll just bring up this upcoming events slide. So this is all of the events Weld Australia has planned for the next couple of months. One of the soonest ones coming up is this ASME 9 course, which is a 3-day course, which is presented by an international expert from the United States. So if anyone's also interested in any of these events, please visit our events page on our website, or feel free to reach out to me or anyone else within Weld Australia or within one of our teams. But yes, that's pretty much it from me, everyone. So to basically just summarize, one thing that we need to definitely do is have a look at what government incentives are currently available for the adoption of technology. Pursue those. Also get in touch with me, as we are pretty much revamping in Weld Australia the Advanced Manufacturing Industry Network. We want to solidify and consolidate that into a definite network where we could then advocate to the government on behalf of our member base and on behalf of the welding industry in Australia. So please reach out to me if you are interested in being a part of an industry network that looks at automation and that looks at the current issues, and we will try and attack and solve those issues as a group. So yes, please feel free to just drop me an email if you're interested in being part of that. And also feel free to get in touch with me regarding our tech suppliers who presented today. If you're interested in Smenco or Diversico or any other tech suppliers within our network, we do have Freelance Robotics is also part of our network. Lincoln Electric is also part of our network. So please get in touch with regards to that. And yes, exciting things to come. So thank you, everyone, for joining us today. And yes, I bid you a very good day and a good week. Thank you, everyone. We will see you again soon.
Thank you, Cornelius.
Thanks, Cornelius.
Thank you,
Thank you.
Corey.
Thank you very much.
Thanks.